Welcome to Cyber Platter. Today we will review Domain 1 of CCSP. This video is a quick recap of Domain 1 of CCSP. Maybe you can listen to it before you're starting your studies for CCSP or a day or two before your exam to revise what you have already studied or to revise whenever you completed Domain 1 studying, right? ISC Square provides a free quiz which has 10 questions that is somewhat similar to the exam. So if you want to know how prepared you are, I highly recommend to take up that quiz. I have added the link in the description so you can access it and take it. Okay, now let's start with the review. Here are some of the important pointers. Cloud customer is ultimately responsible for the data and its security, even though it is cloud provider's fault in security breach, right? Building blocks of cloud computing are CPU, memory, storage, and networking. Security always comes with a cost and it reduces quality of service. Security decisions are driven by the organization's business needs. Automation helps continuous security monitoring and reporting in cloud. Cyclic applications, that is, the applications which have varying demands, are best suited for cloud. Orchestration and virtualization form cloud. Economies of scale are very much in favor of larger entities. That is, higher the price per unit, the smaller will be the scale. When the scale increases, becomes larger, then the price per unit goes lower. Security controls in cloud may reduce the financial benefits of the cloud. The primary mechanisms for delivering cloud compute resources include virtual machines, serverless computing, and containers. Elimination of risks is not possible even with cloud migration. Cost benefit analysis. Cost is a key factor in cloud adoption, but there are other factors as well. Resource pooling, factor in time and efficiencies, include depreciation, reduction in maintenance and configuration time, shift in focus, utility costs, software and licensing costs, paper usage, all of these reduce costs in cloud. CapEx, this is important point. Capital expenditure is shifted to operational expenditure in cloud. This reduces cash flow risks. By spreading costs over time, a business can reduce the risk that there will be no lack of money at any given time. No upfront cost or physical hardware cost would be more beneficial to a new company that is getting started. If you see here, there is upfront cost. It is very significant in traditional data centers, but in cloud it is none. Ongoing cost is low in traditional, but it is based on storage in cloud. Tax deduction is over time in traditional. It is at the same year in OPEX model. Early termination, no, anytime in cloud. Maintenance, significant in traditional, low in cloud. Value over time, it lowers in traditional, there is no change in cloud. Interoperability, desire for compatibility of services between cloud service providers, ability to split up and reuse components throughout the systems and applications. You have to avoid proprietary formats and technology. Portability, easily and seamlessly move between different cloud providers. For example, when it comes into picture, disaster recovery reasons, locality diversity, or high availability. Portability is the most affected in the case of vendor lock-in and vendor lockout. Containerization supports portability by packaging workloads in a standardized manner. Here as well, you have to avoid proprietary formats and technology. You have to ensure favorable contract terms, and you should always have an exit strategy from day one. Vendor lock-in. It is a situation in which a customer is unable to leave, migrate, or transfer from one cloud provider to another to situations like using due to situations like using proprietary formats or unfavorable contractual agreements. Vendor lockout is a situation where a customer is unable to recover or access their own data due to the cloud provider going into bankruptcy or otherwise leaving the market. Good background verification, including financial status of the cloud provider before moving to cloud, might help in avoiding vendor lockout. The roles in cloud computing, this is provided by ISO IEC 17789, Cloud Reference Architecture. Cloud service provider is the one who offers the cloud services. Cloud service customer is a one who consumes the cloud services. Cloud service user uses the services provided by the cloud provider. For example, an organization can be called as a customer and the employees in the organization are the users. Cloud service broker. Cloud service broker purchases services from cloud provider and resells it to its own customers. It provides service intermediation, aggregation, and arbitrage. Cloud carrier, intermediaries providing connectivity and transport of cloud services between provider and customer. Example, an ISP. Cloud service partner supports the provision, use, or other activities of the provider, customer, or both. This is important. Cloud Access Security Broker, CASB, provides IAM, identity and access management services to providers and customers, single sign-on, SSO, certificate management, cryptographic key escrow, and monitoring. Cloud operator, responsible for daily operational tasks. Cloud Service Operations Manager oversees and manages the operations and performance of cloud services provided to the customers. Technical Account Manager provides account support and high-level technical guidance to cloud customers. Cloud Service Integrator, connecting and integrating existing services and apps with cloud-based services. Cloud Service Admin, testing, monitoring, and securing cloud services. It also, admin provides usage reporting and deals with service problems. Cloud Application Architect, adapt, porting, and deploy the application. Cloud Architect designs, develops, and manages solutions. Cloud Data Architect ensures the various storage types utilized in a cloud environment and able to manage the SLA. Cloud Service Manager responsible for business agreement pricing for the cloud customer. Cloud Storage Admin mapping bandwidth and manages storage volume assigned. Cloud Service Business Manager oversees business and billing administration. NIST SP 800-145 Cloud Concepts and Cloud Definition. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model is composed of 5 essential characteristics. On-demand self-service computing. Cloud resources may be rapidly provisioned with no or minimal service provider interaction. Cons: lack of governance. Broad network access. Cloud resources can be accessed from any device, any location over the internet. Cons is how to manage the bring your own devices, how to provide secure access, as the data can be anywhere. Legal compliance is complicated. Resource pooling and multi-tenancy, abstraction and apportion of resources across multiple consumers. Cons, makes audit difficult, resource exhaustion, inference, information leakage, VM to VM and VM to hypervisor compromise. Forensics is difficult, data destruction is complicated. Rapid elasticity and scalability. Let's see what is scalability first. Scalability, when the amount of servers increases or decreases, that is called as horizontal scaling. When it decreases, it is scaling in. When the number of resources increase, that is called as scaling out. Vertical scaling. In vertical scaling, the size or power of the server, CPU, memory, storage increases. Okay. Scaling down is when the size goes down. Scaling up is when the size goes up. Rapid elasticity is nothing but automatic scaling. Automatic provisioning and deprovisioning. Cons, abuse of cloud services. Example, DDoS attack or DOS attack on cloud can result in provisioning a lot of resources, hence increasing the cost. Measured service, pay as you go, pay for only what you use. Cloud service models. Security in the cloud follows the shared responsibility model where vendors and customers have different responsibilities depending upon the strategy of cloud service, like how it is shown in this image. In all cloud deployment or service models, one can assign or transfer responsibility but not necessarily accountability. Infrastructure as a service. Provider offers customers basic building blocks of compute, storage, and networking. The primary benefit to the customer is the transfer of cost of ownership. Here we usually use object and volume storage. Platform as a service. Here, provider offers customers a platform upon which they can execute their own code. It is best suited for development and testing activities. Here, structured and unstructured storage types are used. Structured is very well organized data, example relational database. Unstructured is can be like video file, text file, image file. Concerns, backdoors created by the developers. Software as a service, provider offers customers a complete application ready to use and delivered over the internet. Storage types here are content and file storage, the data that is within the application. Information storage and management, the data entered in system through web UI. Ephemeral storage, CDNs, raw storage, long-term storage. Cloud deployment models. Choosing cloud solution is a business decision. Public cloud, offered to any customer in a shared environment built upon the principle of multi-tenancy. There is no wasted resources here, easy and inexpensive, cons is limited security control and ownership. Private cloud, operated for a single customer in a dedicated environment. Ownership retention is a unique benefit here. Maybe this private cloud can be internal or external to an organization. Cons, initial capex. Hybrid cloud, mixing the use of public and private cloud resources. Used in BCP and cloud bursting. Portability and interoperability are very important here. Cons, complicated to manage. If you see here, if you use hybrid cloud, you can get the advantage of both private and public cloud. Like for sensitive and critical data, you're using private cloud, and for non-sensitive and non-critical data, you use public cloud. In private cloud, you get ownership and security control. In public cloud, you can save money. Community cloud offered to members of a closed group of customers, for example, gamers. Cloud bursting, dynamic development of applications that normally run on a private cloud into a public cloud to meet expanding capacity requirements and handle increased demands when private cloud resources are insufficient. Suppose, say, at this level you're using private cloud, and as soon as the demand increases, you start using the private cloud. DDoS attacks do not affect the productivity but rather availability for cloud customers. Transparency, official process by which a cloud provider discloses insight and information into its configurations or operations to the appropriate audiences. Reversibility, the ability for a cloud customer to remove all its data and IT assets from a cloud provider. It is related to right to be forgotten. Let's talk about the storage types. The first one is object storage. It is less expensive. It has unique address identifiers and metadata. Hence, it has better indexing, which helps in enforcing data policies. This is very helpful in DLP and IRM. It is a flat file system accessed through opaque handler or descriptor. It allows to store files as individual objects but can't be directly mounted by an operating system. Key or token value. Access through APIs or web interface, limited to uploading, storing, and manipulating files. You can only do this, but you cannot install or run programs in object storage. Usually, virtual images are stored in object storage. Volume storage, represented as attached drives to the virtual machines. There are two types of volume storage: file storage and block storage. Along with accessing, uploading, storing, manipulating files, you can also install and run programs here. Block storage uses iSCSI protocol. iSCSI does not natively support encryption. When volume storage is allocated to a host, it is called as LUN, logical unit. Ephemeral storage is also called as temporary storage, is a SAS storage that exists only as long as its instance is up. Content Delivery Networks, CDN, is SAS storage that occurs when content is stored in object storage, which is then distributed to multiple geographically distributed nodes to improve internet consumption speed. Caching is the keyword here. Data fluidity. Data is fluid in cloud computing, that is from on-prem to off-prem. Virtual private clouds, VPCs, are like VLANs on a physical network. Access to cloud resources can be controlled through the use of network security groups, which implement firewall-like functionality. Cloud Application Management Platforms, CAMS, set of specification designed to ease management of applications, including packaging and deployment across public and private cloud platforms. Performance. Provisioning, elasticity, and other associated components should always focus on performance. Governance defines actions, assign responsibilities, and verify performance. Access relevant reporting, metrics, and up-to-date statistics related to usage. SLAs. In the SLA, the minimum levels of service availability, security controls, processes, communication, support, and many other crucial business elements are stated and agreed upon by both the parties. An SLA should include specific metrics. Key term here is measurable. Auditability, increased confidence, and the ability to have evidence to support audits. Resilience, ability to operate in the event of disruption or disaster. Monitoring and high availability. Orchestration. Automated cloud management is orchestration. It builds upon the concept of infrastructure as code. It is very much used in DevOps. Manage and provision infrastructure through code instead of doing it manually. Benefits of orchestration, a few of them are reduce errors, increase in speed of deployments, cost reduction, improve infrastructure consistency, eliminate configuration drift. It also provides standardization across the environment. Cloud provisioning is the deployment of a company's cloud computing strategy. It determines what services are supposed to be in the public cloud or private cloud or which will remain on site. Management plane allows admin to manage any or all of the hosts remotely. Management plane breach is the most significant risk in the cloud environment. Remember this, that the management plane breach is the most significant risk. Forklifting, process of migrating entire app the way it runs in a traditional environment with minimal code changes. Not all the applications are cloud ready. Shadow IT occurs when cloud users access and use cloud systems and resources that have not been authorized by their organization. This is expense of no use. Multi-tenancy or resource sharing. Reservations, guaranteed minimum resources for customers. Limits is the opposite of reservations, is the guaranteed maximum resources for tenants. Shares, a prioritization and weighting system within a cloud environment that says the order of specific applications or customers to receive additional resources when requested or when there is resource contention. Borrowing, when a limit is allowed to adjust to temporary and changing conditions within the cloud environment, it is referred to as virtual machine introspection. VMI allows for agentless retrieval of the guest OS states, that is running processes, active network connection, what are the open files. This is highly used in malware analysis, forensics of the memory. So if you see this picture, you can see type 1 hypervisor is installed on the bare metal and type 2 is on the host OS. There is an extra layer here. That means more attack surface. Type 1 is considered to be more secure than type 2. Running on top of another operating system versus being tied directly to the hardware is a major security risk with type 2 hypervisor. In a virtualized environment, the hypervisor is responsible for enforcing isolation. Hyperjacking. An attack on the hypervisor where a hacker takes malicious control over the hypervisor. Example, blue pill hypervisor rootkit. VM escape. A user on a VM can escape from it and take control over the whole hypervisor. Co-location concerns. Multiple VMs residing on a single server and sharing the same resources increase the attack surface and the risk of VM to VM or VM to hypervisor compromise. On the other hand, when a physical server is off, it is safe from attacks. However, when a VM comes offline, it is still available as VM image files that are susceptible to malware infections and patching. Instant on gap. When a VM is turned on after being dormant for some time, the VM might not be secure because of the missed patches and updates. Cloud data lifecycle. This is not truly a cycle because the data does not continue after the destroyed phase. First one is create, creation, acquisition, and altering data. Here, the data classification occurs. The next one is store. This is the first stage where security controls are implemented. Encryption and rest is used for data security. Use, view or process data. Altering is not considered as use, altering is considered as create. Usage of DRM and DLP for data security. Share, DRM, DLP, SSL, TLS are used for data security. Archive is long-term storage. You should retain the data as per the policy. Destroy, crypto shredding should be used in cloud. Crypto shredding is the best sanitization option in cloud. Here we encrypt the data with key A and encrypt the key A with key B, delete the data, delete both the keys. Common threats in cloud, data breaches, countermeasure is encryption and defense in depth, data loss and countermeasure backups, strong key management, account or service traffic hijacking. This usually done through social engineering like phishing. So awareness is the key here. Insecure interfaces and APIs. API hygiene should be implemented. Denial of service. We should make sure to reduce single point of failures. Malicious insiders, separation of duties should be implemented. Abuse of cloud services like DDoS attacks, dictionary attacks, password cracking. Insufficient due diligence. You should always make sure to have an exit strategy. You should make sure to check the security practices of the cloud provider. Shared technology vulnerabilities, defense in depth should be implemented. Key Management System, KMS. Separation of duties is very important. Key managers should be separate from providers. Keys kept on premises in an isolated, secure location. Approaches for cloud computing, key management. Remote key management. Customer maintains the key management system on premises. Connectivity is required between KMS server and encrypted cloud data for encryption or decryption. Availability might be an issue here as the data and the key are in two different environments. Remote key management is usually used in infrastructure as a service. Client-side key management. Provider provides the KMS, but it resides on customer premises. Customer generates keys, encrypts data, and uploads it to the cloud, usually used in SaaS. FedRAMP. FedRAMP is a regulatory framework that the United States federal government uses to assess and certify cloud services for their use by federal agencies. ISO IEC 27001 is commonly applied to cloud computing security as a standard and certification system for promoting and continually improving upon the security applied to a system or application. It does not recommend any technology. ISO IEC 27001 is vendor neutral. Evaluate cloud service providers. Verification against criteria. It has two important ones, that is PCI DSS and IOC IEC 27017. PCI DSS is a set of mandatory security requirements for organizations involved in credit card processing. It distinguishes merchants by different levels based on the number of transactions per year. If you see, level 1 is the highest, level 4 is the lowest. 1 has 6 million and above transaction, level 2 is 1 to 6 million, level 3 is 27,000 to 1 million, 4th level is less than 20,000 transactions. PCI DSS requires that the Credit card verification number should never be stored for any length of time. Credit card data should be either encrypted or tokenized. ISO IEC 27017, this offers an international standard for cloud computing security that organizations may voluntarily adopt. It provides cloud-based guidance on ISO IEC 27002 controls. System or subsystem product certification. Product certifications, here we are referring to FIPS and common criteria. Federal government agencies require that services they use be certified under the common criteria and that encryption used to support them be compliant with FIPS 142. Common criteria is an international set of guidelines and specifications for evaluating IS products to ensure they meet security standards for government entities. It needs to be verified by vendor neutral third party. Common criteria tells us how thoroughly the product has been tested. It's also called ISO 15408. So if you see, eval is the lowest, EAL7 is the highest. It is evaluation assurance levels, EAL. Target of evaluation is the device or system that is being reviewed. Protection profile describes what does the customer need. Security target, vendor's claim of the security. Evaluation assurance levels, how thoroughly the product is tested. Level 1, functionally tested. Level 2 is structurally tested. Level 3 is methodically tested and checked. Level 4 is methodically designed, tested and reviewed. Fifth one is semi-formally designed and tested. Sixth one is semi-formally verified, designed and tested. Seventh one is formally verified, designed and tested. FIPS 142 Federal Information Processing Standard. Validated certification was established to aid in the protection of digitally stored, unclassified yet sensitive information. Remember, it is for unclassified yet sensitive information. Publicly announced standards developed by NIST for use in computer systems by non-military American government agencies and government contractors. FIPS security level, 1 being the lowest security and 4 being the highest security. Level 1 standard OS, no physical security. Level 2 is tamper evident seals. Level 3 is tamper resistant controls. Level 4 is strict physical security. Upon tamper detection, immediate zeroization of plaintext critical security parameter. That'll be all for today, guys. Domain 1 review is complete. If at all I've missed anything, please add it in the comments, and I will also make sure to cover it in the other videos. If you liked what you heard today, or if you learned something from today's video, please like, subscribe, and share our video. Thank you very much. Bye-bye. Borrowing.